Hello everybody. In this video, we are going to solve another problem on LeetCode Live. Today, we are going to pick a problem of medium difficulty. I have the problem list already filtered by medium. We have already done add two numbers. If you haven't checked out my video on that problem, please go to my channel and check it out. Today, we are going to try to do the next one, which is longest substring without repeating characters. Okay. So let's read the problem. Given a string S, find the length of the longest substring without repeating characters. Okay, that's pretty self-explanatory. The examples are ABC, ABCBB, and in this case, the longest is 3. Yeah, it's ABC. In fact, it could be ABC, BCA, or CAB, or even this ABC. But anyway, it doesn't matter. We don't have to figure out how many there are. We just have to return the number of the length of the maximum or the longest substring that does not have repeating characters. The second example is BBBBB, and of course the output is 1 in that case. Third example is PWWKEW. Yeah, so in this case it's 3, yeah, it's WKE basically, and then in fact it can also be KW. Okay, so what are they saying here? Notice that the answer must be a substring. PWKE is a subsequence and not a substring. Yeah, I mean, that makes sense. Subsequence is used to describe, a subset of characters which are left to right in the original string, but not necessarily next to each other, right? But anyway, substring is a very standard term, so that makes sense, but good that they clarified that. Okay, constraints. The length of the string is between 0 and 50,000 inclusive, and the string contains English letters, digits, symbols, and spaces. Yeah, okay. I mean, this is important just to probably make sure that we just do a simple comparison for a character when we are checking for its existence. But yeah, I mean, we'll basically use exact match, and that should take care of all of this. Okay. So with that, let's figure out an approach, right? So I mean, every such problem, and we have done a few on this channel, there is always a brute force approach, right? So we basically can check all substrings. So one approach is we say brute force. Basically, the description is, if check all substrings, if there are no repeating chars, then just update max length, right, based on how long that substring is, and that would work. And just to very quickly kind of get an idea of the time complexity of such an implementation, there are going to be n square different substrings, right, different values of left and right. So O of n square is just to kind of try out all the various substrings, and then for each substring we have to figure out if it has any repeating characters or whether all the characters are unique, right? And that depends on how we do it. It could be linear time because we are scanning through the whole array and just storing each character in a data structure like a hash set or a hash table, hash map, I mean. And we can very quickly check whether a character already appeared in the string, right? So for example, if you take this one, and let's say we are taking the substring that is the whole string, right? In this case, once we have seen ABC are in some hash map, right, or a hash set. So after that, when you actually check for A, you will check in the hash map whether A existed, and hash map will tell us very, very quickly, or even a hash set, right? So if we do that, then it is linear time to figure out whether a string has all unique characters. But if we don't want to do the extra memory for that, then after ABC comes, in order to figure out whether A existed, you have to traverse the entire substring before us, right? And that is another O of n. So it becomes O of n squared just to check whether a string has all unique characters or not. And that is done O of n squared times. So it could be O of n raised to 4 algorithm, right? So this brute force approach can be O of n to the power of 4, or it could be O of n to the power of 3, right? Depending on whether we use extra memory, right? Okay, so that's that. And we are not going to implement any of that because I think we have implemented enough such problems with brute force on this channel. If you're interested, you can take a look at the other videos on my channel. Okay, so let's figure out the a more efficient algorithm. Okay, so I mean, when I was reading these examples and figuring out what's the answer for that, one approach that probably you also thought about is, hey, we can just start from left and keep going right and see like whether we can extend the substring, right? For example, in this case, let me write it here again. I'll start a new comment because it's a new approach. So what we could do is we can say, okay, in this string, let's start with A, right? And then let's see if we can add another character to it. And the way we see it is we say, okay, so initially our substring is defined by L equal to 0, a left equal to 0, and a right equal to 0, right? So initially this is our substring, which means our substring is just A, right? So substring is just A. Okay. So now we say, okay, let's expand the substring by adding one more character at the end, right? So L equal to 0 and R is 1. Okay. Now that means we are trying to append B to the string A. And we check whether B exists in the string A. And the reason string A is because string A is represented by L0 and R0, right? Or substring A. So I should call this SSA. Okay. So here we say, okay, B doesn't exist, so I'm going to make my substring bigger. Okay, sounds good. In that case, we keep on going. We keep on trying to expand by incrementing the right pointer, right? Now we are trying to add C to this substring, and C does not exist in the substring AB, so we can actually expand ABC, right? AB to ABC. Okay, we keep going. We say, now R is equal to 3. Things are going good, right? Okay, now we come up with our first duplicate, right? So what do? We say, okay, ABC, we cannot add A to it because A already exists. Then what do? We can't add A, but what we do is we can actually remove that last A, and we say, okay, now our the first A, or the first character rather, it may not be A. The A could be in the middle. Like if this string was BAC, then A could be in the middle. But let's take this example for now, right? So we remove A and we still don't increment R, but what we did is we incremented L, right? Again, we have not yet added the character at R. So R remains at 3. We are still trying to add it, right? Okay, we say, okay, BC, can we add A to it? We say, yeah, we can add A to it because A doesn't appear. So we are going to increment R now this time. And L stays the same, right? But now we are going to try to add B to BCA. That's the next character. And that's where we say, hey, does B exist in BCA? It does. So we cannot do it. Let's trim down that substring from the left side, which means our left becomes 2, R remains at 4, and that makes the substring CA. But now we are trying to add R equal to 4 character, which is B, right? And now we can add that, and so on and so forth. So if we do this, then I think and this point let's actually finish this example, even though it becomes a bit longer. Okay, so now in this case, since we incremented R. What are we trying to do? We are trying to add the character at R equal to 5, which is C, to CAB. We say, no, we can't add it. So we are going to trim down, and we increment R. We trim down the string on the left side, and we again try to append C to it. And this time we will be able to add C to it, right? And then similarly, since we were able to add, we'll do R equal to 6. Now this time, what are we trying to add? We are trying to add B to ABC. Yeah, this is a good example. So we trim down because B exists, but that doesn't remove B, right? Because B was somewhere in the middle. It wasn't the first character of the substring, and that's fine. And that's because since we trim down, we are going to increment L, and then we will remove B, right? So we'll say R still stays at 6, or we still cannot add a B, so we again trim more. And then finally, after L is 5 and R is 6, that's when we can add a B. Of course, that's not the longest substring, but that actually demonstrates the algorithm, right? And so on and so forth. I think at this point I can stop. And that is our algorithm, right? Okay, so now before we implement it, we have to figure out one very important detail, and that's how do we check whether a specific character appears in a particular string, right? String represented by a specific L and R. Well, I mean, we said in the previous one that in order to efficiently check, we should actually use a hash-based data structure. And since here we don't need a key value pair, we only need keys, which are characters, we can actually use a hash set, right? And that will be efficient way to actually figure out whether a character is already there in the substring. Okay, and we keep the hash set up to date, right? Whenever we append a character, we will add that to the hash set. Whenever we trim down the string, we remove that character from the hash set. Okay, so let's try to implement this approach. So we need a hash set, and in Java, and I've said this a few times on this channel, anytime we use collections from the Java collections library, we have to use collections of objects, right? And we cannot use collections of basic data types like int or bool or boolean or char or double and stuff like that, right? We have to use their corresponding classes, and the corresponding class for char is character. I say let's call it char set, actually not map, char set equal to new hash set. There you go. And this is where we will store whatever we are appending, and remove when we need to remove. Okay, what else? Well, we need a left and a right. Okay, and yeah, we need to keep track of max length, right? I mean, here in the algorithm, actually I said substring, but that was just to show what we were checking. All we need to keep track of is the maximum length of the substring. So far it initially starts at 0. Okay, and then the while loop goes to right is less than s dot length, right? Well, left ever pass right is what I'm thinking about. Actually, it could, I think. So let's actually do this for now, and I'm going to come back to that, whether we strictly need both the conditions or... Okay, so while they both are less than, which means they both are valid indices, right? Okay, what do? We first look at the character at the right index, right? So s dot char at right. Okay, so that's our char, and then we try to find that character inside our hash set. So we say if char set dot, I think it's dot contains. Actually, let me just open Java hash set. Well, actually, I could also look at the set interface documentation because hash set implements it, but anyway. Okay, so we have contains. Yeah, there you go. Okay, so dot contains and ch. I mean, I remember the hash set is of character object, and we are using a char, but Java will implicitly convert that into a character object, which is called boxing, if you didn't know that. Okay, it boxes a basic data type into an object. That's why it's called boxing. Okay, so char set dot contains ch. If it is already there, then what we do? We actually increment left, right? And we have to remove that character, remove the character at the left. We cannot remove ch, remember that, because ch could be somewhere in the middle, but we remove the character actually, yeah, so I should remove it first, right? Because I already incremented left. So what I do is I say char set dot, what is it, remove? Yeah, remove right here, remove, and we say s dot char at left, right? Because that's the one we are peeling off from the left side, not ch. Sometimes it could be ch, sometimes. Okay, so that's what we do if it is there. If it is not there, what do? We say char set dot add. I think I just saw add. Yeah, add, and we just add ch, and then we just say plus right. Okay. Okay, and in both the cases, I mean, we could do it. Actually, I think we should do it even when we increment left, but we basically have to keep track of what is our substring length. Our substring length is right minus left, correct? And we say max len equal to math dot max len comma len, right? That is the length of a substring. I was trying to figure out if it's right minus left or right minus left plus 1. Well, I mean, right would have been incremented. So yeah, I think it's right minus left, not right minus left plus 1. And it won't always be incremented, but here it will be, left will be incremented, but still I think right minus left gives us the right answer. Okay. So if not, I think we'll hopefully see a failed test case. Yeah, yeah, I think it works. We could actually, let's check with one example, right? So in this case, for example, yeah, we would have incremented r, right, in this case because we appended it, and that will be the new length of substring. So 0,3. Yeah, so that should work. Okay. Okay, so then here we just say return max len, I think. Are we missing anything? I think that is all, right? Our algorithm was, yeah, I think that is all. We increment r, which appends it. We calculate the new length by right minus left. Yep. And then we just update the max length. Okay, yeah, I think, let's see. Okay, cool. So that did work, which is great. Let me try to submit this. I mean, actually, before we submit it, let's go through the complexity, right? I mean, it's pretty obvious. The complexity is of n, right? We are just scanning from left to right once. Sometimes we update only right, and sometimes we update only left, right? So that is O of n complexity. We never kind of go back, right? We don't do minus minus left or anything like that. So we are kind of just going to go through with a sliding window through the whole string, expanding the string, sometimes shrinking, expanding, shrinking, and so on. Okay, I think that then let's submit it and see how we are performing, and also run more test cases. Okay, so we beat 68% people. Okay, I was hoping for more. Our implementation is quite compact. Memory is good. I mean, my hash set is probably what most implementations who need to run fast use. Otherwise, that becomes an O of n complexity by itself. Okay, so memory is good. Why is, I wonder why. I mean, one thing I was thinking about when the case where it appears in the middle, right? So for example, let me actually take a general case. Let's say we are checking some substring like this, right? And let's say we are trying to append x to it, right? And this is the substring defined by, left and right. And we are trying to, and let's say x is somewhere in the middle here. So let me add a couple of dots, right? So right now our algorithm will peel off one character and then go to the next one. It will again peel off and again peel off until it peels off everything until the x, right? And only then it will be able to add x. What I was thinking is, instead of using a hash set, if we use a hash map and put the index of x in the hash map as a value, key is still the character, but the value, then can we jump directly to the one after that, is what I was wondering about. Yeah, I think we can, right? And it doesn't change our complexity, it's still O of n, but in some inputs, it might actually run faster, right? And that might improve our time here. Let me try that. I don't want to ruin this, so I'm going to take this in a, make it full screen. One second. I'm going to take this in a helper actually, because yeah. Okay, so let's say, okay, and let me just paste this for now. Okay, let's try to implement that other approach. I think we could still probably start from this one, but actually let me do the following. Copy the whole thing. Just have to change the name then. Okay, so then we go here and we copy that. Let's say with map, right? And what we are doing this time is we are creating a hash map where the key is the character, the value is the index. Okay, and then this is a map. Actually, let's call it char map, of course. Left, right, max, then this still stays the same. Okay, now a bunch of these method names might be different. So one second. So this char map, okay. Let's do Java hash map. I think contains key now because, oh, but we want to, if it is there, then we want to get it, right? So I think instead of using contains key, we should do get or default. I think I looked up that method in doing one of the, yeah. So I think what we need is here like this, integer priv index, right? The previous index of character ch equals char map dot get or default. And the reason I'm doing that instead of contains key is that if it contains the key, we want the value, right? So instead of first checking contains key and then saying, okay, now that it contains, give me the value, get or default actually will do that operation for us. Okay, so we say we are still looking up ch, but the default value is null. So we are saying if it doesn't exist, then just say null. Okay, so priv index is not equal to null, which means it existed. Then we remove, now we are going to skip to +1, right? So instead of left plus plus, we say left equal to, oh, we need to remove a bunch of characters, right? Okay, so that becomes an issue. So in this example, basically going, let me take that example down here 1 second. So for this implementation, we are trying to optimize this case, right? So in this example, when we look up x in the map, it will give us the index, but we need to remove all of these from the map, everything before x, including the x, and that's linear time, right? So that's a bummer. So maybe this approach doesn't work. 1 sec. No, wait, so okay. No, okay. So we can do one trick. Okay, so we don't have to literally remove everything. What we can do, we will update left to this one, right? To the index after the x, right? So if the value of any of the variables, sorry, any of the characters is before left, then we assume it is not in the substring, right? I don't know if I explained that very well, but what I mean is not equal to null and priv index is greater than, which means there is a previous index for the current character, and that index is actually greater or equal to left. Only then we should consider that character existed, right? And only then we say yes, I think this will work. We say left equal to priv index dot, actually we should do int value, 1 second, yeah, +1, and yeah, we don't have to remove it, we just update its index, right? In fact, we can do just this much and not update right, and in the next turn it will automatically add that. We don't do anything here, right? So we updated left to the one after that, and we didn't update right. Since we did not update right, in the next iteration, it should automatically find that it does not exist. Well, actually, without removing it will, yeah, it will automatically find that it does not exist, and it will add it. And this time we don't add, we have to put, and we have to do ch, and we have to do right. That is where that character exists. Yeah. And in fact, this just becomes a for loop now on the right pointer, I think. Yeah, basically we can always update right? So, okay, so sorry about the mess, but I think I'm thinking aloud and doing live problem. That's the fun. So what I'm saying is, right can always go 1. And the reason is because if the character did not exist, that's easy, right? We can increment right. But even if the character existed, we can increment right because of what we did in this if condition, right? Here we are going to do this, and we will update our map by removing that character, removing ch. Let me add code for that. But if we do that, then we can always do this. We don't need an else here, right? It will be char map and it will be plus plus right, but plus plus right meaning I will do it as part of the for loop, right? So this goes away. Sorry, one second, let me get everything in order. This became very interesting. For right equal to 0, right is less than s dot length, there you go, and plus plus right. Yeah, and now, yeah, we get the character. So okay, so we always increment, right? We get the character, we look up the previous index of that character in our map. If that index is within bounds, which means it is there and it is actually greater or equal to left, only then it is part of the substring that we are trying to append to, right? Then we actually update left equal to priv index plus 1, and we also remove them from the map. We say char map dot I think remove or remove key or something. One second. Remove the, yes, just remove, right? And we just say ch, right? And so if it existed, we would have trimmed the whole substring, we would have updated left, but we always update right? So we again put that character in the map because we are going to append it. And this time the length is, I think, right minus length plus 1, because the plus plus right only happens in the for loop, right? So that's why this will be the thing, and then we do this. Yeah, I did that in a very messy way. I'm not sure if it's gonna work, but I think the approach should work. I'm not sure if I have any bugs. I think that's what I mean. Let's try it though. Yes. Okay, so let's run it. Oh, that's cool. So it did accept here. Well, does it actually exercise that optimization? I think it does. Like in here, when it looks at this B, it's going to remove the middle B and directly jump to the C. But let's submit this and see. The very reason we tried this to beat more in time, does that work? Oh, cool. It did work. Okay, so that was the suspicion, is that the time complexity is exactly the same of n, but in practice, we are now faster for certain inputs. Okay, sorry about the mess there, but I hope it makes sense what I did there. Yeah, if you're liking what I'm doing on this channel, please consider subscribing to my channel and hit that thumbs up button on the video if you can. See you guys next time.